to get vented out of the tank if the tank pressure gets too high. The other thing is, if there's an event of a fire, same type of thing. It's going to cause the pressures to increase. Now, the pressure relief device for heat is like a lead plug that melts out and allows the tank to vent. That is going to be between 212 and about 266 degrees. So I have two actual pressure relief devices that are on part of the valve. One has to do with pressure, the other has to do with heat. It's all designed to get rid of the pressure in the tank and allow it to go to the atmosphere. Sure, there's a fire going on, but what would you rather have? A little extra flame or a big boom that can do more damage to people? I think I'd rather have a little extra flame myself. Okay, tank venting. Now, if the tanks are underneath the car, tank venting, no big deal. We can just let them vent. But if it's actually mounted inside a passenger compartment, like behind the back seat or in the trunk area, then we actually have to run vents outside the vehicle. So, venting the tanks outside the vehicle, the slide that I have here actually shows the tank vent coming from inside the vehicle outside, and then it also shows a 90-degree manual shutoff valve for shutting the system off. On this picture, you're reaching through the wheel well right behind the left rear tire to go in and hit the manual shutoff valve. Another type of manual shutoff valve here shows an actual panel. You cannot have them locked. You can't use a tool. You can have it to where it uses a latch to keep it shut, but there can't be anything to lock the panel to get to the manual shutoff. So it has to be a quarter turn type or a ball for the has to be clearly marked with red, blue, or black letters on a white or a silver background. As you can see, this panel here also has gauges on it to show the high pressures and the low pressures of the system while it's operating, and it does include the fill for the vehicle too. So you could have something as complex as what's shown in the slide here. You could have something that's just where you reach through in the fender well to turn it off. Here's another picture showing the manual shutoff valve and showing the accessibility from the outside, again from underneath. But from the outside, basically you'd be reaching through. So if for something was supposed to happen and you needed to actually turn it off, or you had a major leak under the hood, you could just reach in behind the wheel there and shut the system off and not have to worry about it venting out. If you were doing an add-on system to it, here's a manual shutoff valve, something as simple as that, just as long as it's a 90-degree type, but this is another type of manual shutoff valve. Now, fill valves and filtration. First on fill valves. All fill valves in North America follow NGV 1 standards. That's clearly marked on the actual filling port itself. They're color-coded for different working pressures. Green is 2,400 psi, blue is 3,000, and yellow is 3,600 psi. The fill has to be mounted to withstand a breakaway force of 150 pounds. The hoses that you use for filling it up have a breakaway support on them that is set at 150 pounds. So it would make sense that this has to be mounted to withstand 150 pounds. If you decide to drive away while you're hooked up to it, at least it has to be able to withstand 150 pounds of force. That way the hose will break off and then it'll put in the safeties into effect that are built into the hose instead of you breaking off the fill port and now you're emptying a tank that has 3,600 psi in it. As far as filling it, you have to have enough clearance to be able to allow the nozzle to where you can actually hook up to it to hook up on the vehicle. So when you're thinking about where am I going to put this fill valve and doing a conversion, keep in mind I have to make enough clearance to where I can actually fit my fill for going up to plug it up in there. So if I wanted to put it in where the fuel door is, there might not be enough room for this valve to fit up on there, so I might have to put it in some other area, whether it's outside the vehicle on the side or even under the hood. No matter where you put the fill valve, it has to be able to withstand that 150 pounds worth of force. The other thing to keep in mind is you always want the little cap to be able to fit on and go on there to keep all the dirt out so we can actually utilize it properly. On filtration, the main concern about it is moisture and oil from compressing the natural gas. Just like with an air compressor, when you compress air, do you get moisture out of the air? The answer to that is yes. Same thing. The way the compressor works to compress the natural gas, there is always going to be a little bit of moisture there. There's going to be some oil from the compressor itself. That oil gets transferred to the gas, can actually end up in the tank. If we don't filter it out, the tank can then become overfilled with oil and moisture, and that takes away from the fill capacity of the tank. So we use coalescing filters to actually filter out that, so we can actually use our maximum capacity of the tank. The coalescing filters allow you to drain out that moisture and oil that came from the compressor from it, so it does not get into the vehicle and cause problems with the vehicle. The other thing to keep in mind about filters is when you go to service the filters, you want to make sure that the system has been vented all the way so there's no pressure on it to be able to service the filter. So it is important to make sure that you vent the system before you service a filter. But if all you want to do is drain out the oil and the water accumulation from it, there are drains built in to where you can just open that up and allow it to drain out without having to take the filter off completely. So that's the good thing about that. Next, we'll be talking about pressure regulators. Okay, now we'll be talking about pressure regulators and fuel mixers. First thing I'm going to talk about is the pressure regulators. We have three basic types of regulators that are used. We have a multi-stage system where one regulator takes the tank pressure down in 2 or 3 stages to slightly above or below atmospheric, depending on the engine RPM. Another type is a 2-regulator system. We have a high pressure regulator. It reduces the tank pressure down from about 70 to 180 psi. A low pressure regulator then is going to take it down to, in a couple stages, drops it to just how we measure it in inches of water with a manometer. The next is a single stage system that drops the pressure to about 3,600 psi down to about 40 to 130, allows us to use a valve body and injectors to allow us to inject it into the engine. So depending on the type of system we have, depends on the regulator type system that we use too. This is a single stage regulator here that actually took the system down from our 3,600 psi to a usable pressure of about 40 to 130 psi. Air fuel mixers, we have several different types. First is an air valve type mixer that can be located above the throttle plate, or we have a Venturi mixer, which roughly works the same way. But we can make these to be a closed loop system. The way this works is going to be basically on demand based upon how much air is entered in the engine. It goes through the mixing valve and it actually makes a diaphragm move, which will allow more fuel to go in according to how much fuel is going into, air is going into the engine. Next, we have a throttle body system. Same thing like throttle body fuel injection, except we're going to have a throttle body CNG injector that's going to sit above the throttle plate. We're going to inject the natural gas, and as it goes by the throttle plate, the gas and the air is going to mix together for going into the engine. That is a speed density based system, works pretty much the same way as the speed density throttle body injection systems we had in the 80s. And then most systems today are either multi-point or sequential fuel injection. They utilize a controller that's going to work in conjunction with the OEM PCM for the system operation. Sequential injection is the most current system used, and this is a picture of a sequential type system that can be used on a vehicle, but we have all the components that are there for actually getting the system to work, and then, you the installer get to put this on and go through all the leak checks. Next, after this, we'll be talking about leak testing and repairs. Now, leak testing and repairs. Thorough leak testing is vital in the performance of any CNG system, okay? All leaks have to be repaired that you find. The complete system needs to be tested using natural gas. If you ever have to replace a tank, they have you do some things that'll actually do it to where you can do initial testing without using natural gas, but any final leak testing needs to be done using natural gas at the pressure of the system itself. First type of leak detection that is the most common and also the most popular is soap and water. As long as the soap is not ammonia-based, you can use it on the system. Keep in mind, if it has ammonia-based to it, it's going to be a corrosive to the fuel system that you're putting it on, which isn't very good. Picture here shows Snoop Snope. This actually changes color when you have a leak detected, so it also is an additional aid. But if you aren't using, if you're just using like regular soap and water, you're looking for bubbles. As long as there's bubbles, there's a leak, so you don't want to find any bubbles. The next type of leak detection is an electronic type of leak detector that can do hydrocarbons. Here's one here. Basically, it works the same thing as an AC detector. You turn it on, you adjust it, you go around the system. You're looking for it to sit there and beep. So you have different types that are actually out there on the market. Some are as simple as just a beep. Other ones actually go and actually tell you what the concentration is